Good morning, friends. This is a series of lecture for TYBC Analytical Chemistry students, Semester 5 2019 pattern. And the chapter we are going to deal with thermal methods of analysis. Now here DTA, DSC and TGA. These are the three basic methods of thermal methods of analysis. Now in this lecture we are going to deal with differential scanning calorimeter. Now there is no in this book, or you can say the chapter of syllabus of the analytical chemistry does not include any type of instrumentation of differential scanning calorimeter. So we will skip this part of the instrumentation for differential scanning calorimeter. Only the principle and applications are given for differential scanning calorimeter. So take this point into notice. Now the definition of DSC, that is differential scanning calorimeter, is it is a thermoanalytical technique in which the difference in the amount of heat required to increase the temperature of sample and reference material is measured as a function of temperature. It is a thermoanalytical technique in which difference in the amount of heat is measured, but this amount of heat is required to increase the temperature of sample and the reference material, and it is measured as a function of temperature. So on the x-axis there is we can say temperature. On the y-axis there is amount of heat, that is a delta H. Now here another second definition, alternate definition. Heat energy required to establish a zero temperature difference between the sample and reference material is measured as a function of temperature over time. Now the heat energy is required to establish a zero temperature between the sample and the reference material is measured as a function of temperature or time. Now here the temperature or time, both are plotted on the x-axis. The DSC is used to measure the several characteristics properties of the sample. Now it has two types. DSC has two types: heat flux method and power compensation method. So two types here: heat flux first method type, and the second type is power compensation method type. Now the DSC, differential scanning calorimetry, requires small heating rate. So heating rate is 0.3 to 0.7 degrees centigrade, and small quantity is employed for particular for sample. 1 to 3 milligram sample is taken for the analysis. The method is based on the want of law. So what is the basic principle of the DSC? That method is based on the want of law and melting point depression of eutectic system. So want of law and the method of depression of eutectic system. These are the principles involved in the DSC. So we can say this is the basic part that is related to principle, types and applications, or we can say the principle method. Now the application of DTA and DSC. DTA is used for the qualitative analysis of the sample. Now DTA, what is the difference? Differential temperature analysis, DTA. Now here DTA is used for qualitative analysis of sample. Qualitative analysis is nothing but it is analysis where we get the accurate, or we can say the what type of product is, what type of mixture that can be isolated. It has particularly related names. So what is the particular sample is what is the mixture of the sample, or we can say what is the sample. That name is given in qualitative analysis. So we get the name, particularly name, as a distinguishing test for the qualitative analysis. DTA is used for the qualitative analysis of sample. DSC is used for quantitative estimation. So what is the difference between the DTA and DSC? DTA is used for qualitative estimation, while DSC is used for quantitative estimation. In food industry, DTA is used to characterize the edible fats and oils. So DTA is used to characterize the edible oils and fats that can be characterized by DTA in food industry. Now the next one is DTA is used for high temperature studies of minerals, refractory materials and ceramics. So these are the three points for the DTA. DTA is used for high temperature studies of minerals, refractory materials and ceramics. Now ceramics, for example, FeCrO3, that is one type of ceramic. DTA is used for high temperature studies of minerals, refractory materials and ceramics. Now the next one is the DSC. DSC is used in pharmacy industry. What is the application of DSC? DSC is used in pharmacy industry since to give the accurate results, because it gives the accurate results about the purity of sample. So purity that can be easily determined with the help of DSC. DTA and DSC have been used in pharmaceutical chemistry, determination of product purity, identification of optical isomers, and polymorphism. So DTA and DSC both plays an important role. That can be the role is important in pharmaceutical chemistry, determination of product purity, identification of optical isomers, polymorphism. So these are the four important ones. Pharmaceutical chemistry, it deals with the it has application lies in pharmaceutical industry or pharmaceutical chemistry. Determination of product purity, the product purity that can be determined with the help of DSC. Identification of optical isomers that can be easily identified with the help of DSC. And polymorphism, so one substance exists in more than one forms. That is nothing but polymorphism. And that polymorphism that can be studied with the help of DSC, particularly DSC. Because each polymorphic transition causes an energy change that may be detected by DSC. So here with this content I conclude this lecture. Thank you very much for your patience listening.